Hello, so in this lesson we're going to have a look at what are displacement reactions. Now please make sure your phone is off, you've not got the TV on in the background, you're not playing any games, and you've got your booklet ready to answer the questions at the end. If you're ready, we shall begin. So we're going to have a look at our new information. So last lesson, which I know was quite a while ago, we looked at comparing the reactions of metals when we put them in water or in dilute acid to get a bit of a reactivity series. We could put things like lithium, sodium, and potassium in water and watch them fizz or catch fire. And we could put them in acid as well and see even more reactive. Other metals such as magnesium, we could drop into water and go, nothing really happens. But we could put it into acid and see that it starts bubbling, maybe a bit of effervescence, depending on how much magnesium and how strong the acid is. But there is another way we can work out the reactivity series. And we do that by adding a metal to a solution containing ions of another metal. I know, a little bit confusing at the moment, but we'll try and make it make sense. In that, the less reactive metal will be displaced from the solution and will form a solid. Still a little bit confused, I know. So we're going to have a look at one. I've got a picture. So we're going to take magnesium. Magnesium is a metal and it is solid at the moment. And we're going to add it to a solution of copper sulfate, which is an aqueous solution. So the copper sulfate is an ionic bond. And the magnesium will displace the copper in the solution. And we'll be left with solid copper and magnesium sulfate. It does that because magnesium is more reactive. So magnesium is more reactive. When we say it's more reactive, it is easier to become an ion. The easier it is to become an ion, the more reactive it is. We've got a diagram here. I know, incredibly exciting. Much more fun to do it in real life. But we start off, we've got blue copper sulfate solution here. And we put a bit of magnesium in there. We've got blue copper sulfate and solid magnesium there. We give it a stir and we leave it for a little bit. And we get to this solution. We get a colourless or clear magnesium sulfate solution, and we get a lump of copper at the bottom. So we can extract the copper from it by adding magnesium. We can get the copper out. Comes in very, very handy for doing lots of things that we'll learn more about over the rest of this unit. Now, you'll be pleased to know we don't have to work out the reactivity series ourselves because people have already worked it out. We've got it here. We've got our most reactive one at the top. We've got potassium. So potassium is our most reactive and platinum is our least reactive. You'll notice that we've got loads of metals on here, and we've apart from carbon and hydrogen. They are in there just to show where they are relative to these other elements because they are useful in extracting things. This isn't all of the metals. There are more that can go on here. There's more that can go at the top, there's more that can go at the bottom, there's more that can go in the middle in places. This is a general idea of where we are. Now you don't need to know this off by heart, although it can help, it can save a bit of time. Obviously trying to remember potassium, sodium, calcium, magnesium, aluminium, carbon is really hard to try and remember because there's no particular order they seem to go in. So you might want to look for a mnemonic, which you can find online. I'm not going to tell you that there's any rude ones out there, so definitely do not go looking for the rude ones to help you remember this. So again, don't go looking for the rude ones to help you remember this. So this reactivity series will tell us that an element nearer the top will displace an element nearer the bottom. So elements at the top will displace the elements at the bottom, or displace any element lower down. So we'll have a look at an example. So let's say we had calcium chloride, which is CaCl2, and I was to react it with sodium. Now, if I have a look at my reactivity series, I can go, sodium is above calcium. Sodium is the second one here, and calcium is the next one here. That means my sodium is going to displace my calcium. So I can work out my equation here. I'm now going to get sodium chloride plus calcium. I can finish off my symbol equation at the bottom as well. So I've got CaCl2, my calcium chloride, plus sodium, Na, plus my sodium goes to my sodium chloride, which is NaCl. It's not NaCl2, it's NaCl. If you're unsure about how I've got to this, do go and have a look at the video in the revision section on ions and working out ionic charges, plus calcium. So this isn't balanced at the moment, so I just need to finish off balancing it. Again, if you're not sure about balancing equations, go and look on the revision section at the video on balancing equations and the secret method that I use there. This is doing a displacement reaction. So let's have a look at another one. So I'm going to have iron chloride, which is Fe2Cl3. Oh, sorry, Fe3. Fe2Cl3. And I'm going to add it to copper. I'm going to add copper to that solution, and I'm going to see what happens. So I'm going to find where my iron is on the reactivity series. Iron is up here. And copper is down here. That tells me that iron is more reactive than copper, so the iron won't get displaced. The copper cannot displace it, so there will be no reaction. Put a big cross there, and we can say there is no reaction on this case, because iron is more reactive than copper. Iron is more reactive. Okay, we're now going to have a go at doing some questions. So I want you to complete the word equations for these displacement reactions. So they are all happening. I'm not trying to trick you in any way here. They're all going to happen. These reactions will all happen. So pause the video and complete these. They're the same ones that are in your booklet. Okay, you should now only be listening to my voice if you have completed them. I'm now going to show you the answers. Okay, you can now mark your answers. Hopefully you've got them all correct. If not, just go back and have a little look at where you might have gone wrong and see if you can work out which part you hadn't got quite right. If you're ready, we're now going to move on to the next question. So we've got a table here. I would like you to put either a tick or a yes or a no, whether there will be a reaction. So this time you are looking at the reactivity series. And then I would like you to write which products would be formed. Pause the video now to complete that. You should now only be watching if you have done the table. I'll show you the answers. You can now mark your answers. We're now going to move on to the next question. This one is for higher tier. If you're not doing higher tier, you can skip forwards probably about 30 seconds, maybe a minute, to do the next question. You're going to need to write the balanced symbol equations. There are a few that I'll need to give you just for a bit of help. So copper sulfate is CuSO4. Iron 3 chloride is Fe2Cl3. Sodium carbonate is Na2CO3. And tin chloride, SnCl2, and aluminium carbonate, Al2, big brackets, CO3, close brackets, and a 3. Hopefully that should be all you need to help you do it. You will need your periodic table to work out the charges on your ions. I've given you a few of them there as well to help out. So please pause the video now to complete the balance symbol equations. You should now only be watching if you've completed these symbol equations. The answers are on the screen now. This is a really hard one. If you've got all of these right, please do send me an email telling me you got all of them right, and I will award you a golden ticket. If you struggle with them, do go and watch the video on working out ionic compounds and the video on balanced symbol equations. I'm now going to move on to the last lot of questions. 2 questions here, so please pause the video to answer the questions. You should now only be watching if you have completed those questions, and to reveal the answers now. You can now mark your own answers. Thank you very much for watching the video and doing the questions. Hopefully you've been able to understand it and get an idea about the reactivity series. It will come in useful throughout the rest of this unit. Thank you very much. Have a good day. Take care. Bye-bye.